All right, so let's quickly finish up the remaining questions. So we have this question here, which says use the laws of logarithms to write each of the following in terms of, or in terms of simpler logarithms. Okay, so this one is a simple question. So I'm not going to spend a lot of time doing this because I showed you all the rules of logarithms in the first lesson that we had about logs. So I'm just going to do it quickly. So the first one is the log of 10 base 7. Then we have a to the power 7. Then we have b to the power 3 and c to the power negative 8. So this one is simple. So the first thing that we're going to do is we are going to so the first thing that we're going to do is we're going to split these values that we have so we're going to split these values that we have in brackets. So remember, whenever you find any two values multiplying, any function that has two functions that are multiplying when you're dealing with logs, it means that there was some addition somewhere. So where we have 10 times a to the power 7, it means that we can write this as log 10 base 7, then plus log a to the power 7 base 7, then plus log b to the power 3 base 7, then plus the log of 8 to the power 8 to the c to the power 8, sorry, c to the power negative 8 base 7. So this is very simple. So we have log so we have this logarithm, which is log 7, rather log 10 base 7. I think this is the simplest way we can write them. I don't think there's another way, apart from dropping the powers down. So we can drop the powers down. So this power can drop down there so that we have 7 log a base 7. Then we also have this power dropping down there so that we have 3 log b base 7. Then this negative 8 dropping down as well so that we have negative 8 log c base 7. Okay, so I think this is the simplest way you can write this. I don't think there's another way we can simplify, or I don't think there's another way we can simplify this further. Yeah, so let's take a look at the second one. Because unless you have a calculator, that's when you can find this. Same applies to, I mean, for these others, they actually have letters, so I don't think they can be found easily. Okay, I think this is the simplest. I was trying to think of the other way that we can, maybe we try to change the base of, we try to change the whole logarithm to base 10. Because if we try to change it to base 10, means that this part will become a 1. And then this other part to still remain the same. This one will also still remain the same, even this one. Yeah, so I think this is the simplest way we can write this. I don't know if there is a way we can simplify this further, but according to my own understanding, I think this is the furthest way we can go. Let us go on the next question. So the next one is this one. So we have log, open brackets, we have z squared, then we have x squared plus 4 to the power 3. So this one we can also do the same thing that we did. So we're going to have log z to the power 2, then plus we'll have log x squared plus 4 to the power 3. So you just drop down the powers. So you have 2 log z plus you have 3 log x squared plus 4. Yeah, I think even this one, we can't go further than this. Yeah, we can't go further than this. Let's look at the last one there. So the last one is lean, open brackets, we have omega squared, 4th root of, I don't know if that is w or omega. Then you have t to the power 3, then everything over the root of t plus w. So this one is also simple. Where there's division, it means that there's subtraction. So we can say lean omega squared. Where there's a multiplication, it means that there's addition. So we have lean omega squared plus lean, the 4th root of t to the power 3 can also be written as t to the power 3 over 4. And then we'll have another one, which is a minus. I'm going to write a minus there. Then we have lean square root of what? T plus w. So from there, we can drop down the 2 there. So we have 2 lean omega, then plus this 3 over 4 can also drop down there. So we have 3 over 4 lean t. And then this one can also be written as minus lean t plus w there to the power half. So anything, the square root of anything is just the same as that thing to the power half. So the next thing that we do here is we can drop down the half so that we have 2 lean omega. Then we have plus 3 over 4 lean t. Then this, when this half drops down, we have minus half lean t plus omega. So I think this is also the simplest way we can write this expression. Okay, let's quickly move on to the next one. So the next one is also asking us to do the same. It's saying write each of the following into a single logarithmic, logarithm with a coefficient 1. Okay, so the first one we have is 7 lean t. So we're just going to be applying the rules of logarithms. And then minus 6 lean s, then plus 5 lean omega. I don't know if this is omega or w. So this, what we can do is first to take these coefficients to be powers of the functions there. So this is going to be lean t to the power 7 minus lean s to the power 6 plus lean omega to the power 5. Then when there is subtraction, whenever you're dealing with logarithms, where there's subtractions, it means that you are dividing. So the first function will be lean, open brackets, t to the power 7 over s to the power 6. And then we say close brackets, then we have plus lean omega to the power 5. While there's addition, it means that you are multiplying. So this can be written as lean t to the power 7 times omega to the power 5. So this would be omega to the power 5, t to the power 7. Then everything divided by s to the power 6. So we have written this as a single logarithm with a coefficient 1. Okay, we move on to the next one. The next one is half log z plus 1, then minus 2 log x minus 4 log y minus 3 log z. So this one becomes the power, this one becomes the power, this one becomes the power there, this one becomes the power. So we're going to have log z plus 1 to the power half, and then minus log x to the power 2, minus log y to the power 4, minus log z to the power 3. And then anything to the power half is just the same as the square root of that thing. So we have log square root of z plus 1 minus log x squared minus log y to the power 4 minus log z to the power 3. So whenever you're subtracting according to logarithms, it means that you're dividing. So we divide this, divide by that. So we have log root z plus 1 over x squared, then minus log y to the power 4 minus log z to the power 3. So there's also a minus there. It means that we divide by that again. So it means that we're going to have log root z plus 1 over x squared y to the power 4 in brackets. Then we also have a minus log z to the power 3. So this one will also be dividing because there is a minus there. So we have log the square root of z plus 1, everything divided by x squared y power 4 and z cubed. So this is what we have. So this is the simplified version of part B. Let us look at part C quickly, and then we call it a day. So part C is, we have 2 log x plus y base 3 plus 6 log x minus 1 over 3. Okay, so what you do with this is you first take the powers up. So you take the power up there, you're going to have the log of x plus y base 3 to the power 2. Then you have another, so it's a plus, we have log x to the power 6 minus 1 over 3. So where there is addition there, according to logarithms, if you have addition, means that you are multiplying. So you multiply this and that because they have the same bases. So you only multiply and add logarithms with the same base. So we do we can do the multiplication so that we have log x plus y squared, then x to the power 6 base 3, and then minus 1 over 3. So this is the simplified version of that logarithm. Do we have any questions on how to simplify the logarithms?
Yes.
Okay.
On that one would be. B, can you repeat that one? I got confused.
Hello? Which one?
B.
Okay, so B, I'm just going to go through it quickly. So what you just need to do is to raise the powers. So this power half will go up there. These 2 will go as the power of x. This 4 will go there. This 3 will go there. which implies that you are going to have log z plus 1 to the power half. But we know that anything raised to the power half is just the same as the square root of that thing. So what I mean is that here, instead of writing z plus 1 to the power half, we can just write the square root of z plus 1. And then we put this in brackets. Then we have minus, we have log x to the power 2. Then we also have minus log y to the power 4. Then we have minus log z to the power 3. Then since there is subtraction there, it means that we are dividing. So we have this one and then divide by that, divide by that, divide by that. So what this means is that we're going to have log z plus 1, the square root of z plus 1, then everything divide by this, divide by that, divide by that. Means that we're going to write x squared there, y to the power 4, and z to the power 3 there. So this is what it means. This is the final answer. So the first time I was solving it, I was taking it step by step. I wanted you to understand, but this one, because I've already gone through it, that's why I've decided to just skip some steps and just show you the direct way. Okay, so the video is recorded. In case you've not gotten the point, you can still come and watch that part where I was solving it step by step. All right, so thank you very much for attending tonight's lesson. Let's meet in the next lesson where we're going to discuss how we sketch the lim and log graphs. And then apart from that, we're also going to discuss how we solve logarithmic and exponential, not really exponential, logarithmic and lim functions. Okay, so we are going to have log functions that are going to be in simultaneous form. Some of them that we're going to be solving will be just normal equations involving the rules and the rules and the rules of log and lim functions. Okay, so if you have any questions, feel free to contact using any of these lines on the screen. See you in the next lesson. Shalom, shalom.